Forest regions are systematically delineated based on a combination of ecological factors that collectively define their unique characteristics and capabilities. This approach allows for the classification and description of land units that are similar in response to management activities and disturbance. The criteria used to differentiate one ecological site from another is, well, first of all, climate. So this is Mount Graham in eastern Arizona. And you can see that its elevation at its peak is about 10,500. And you can see that this forest that is up in this mountain is surrounded by desert. And so climate is a very important part of this particular forest region. At broad scales, climate is the dominant criterion for ecological units. It governs energy and moisture gradients, which in turn dictate the types of vegetation that can thrive in a particular area. Regional climate types, such as those in different parts of the world, are fundamental to distinguishing major forest divisions. And so as you go up in elevation here, you go from an arid desert down surrounding their area up into a ponderosa and even into aspen forest near the top. And so all of that is what's playing a role in that is, of course, climate. You're getting a lot of different climates as you go up to the top. And one of my favorite things to do is to take people on a field trip and look at all of the different climate regions as you move up into the mountain. As we look at Mount Graham again and perhaps zoom in a little bit, we get a little bit better understanding of the topography that exists on Mount Graham. And topography plays a major role as well in the development of this particular forest. So if I zoom around here a little bit, let's see if we can get it to rotate just a little bit for us. We're going to tilt it and turn. You're going to see differences on different sides of the mountain. And that's something we call aspect. Aspect is just the direction the slopes are facing. And so as I adjust the rotation of the topography, you can see on this side of the mountain, which is kind of the north-facing slopes up here, things tend to be a little bit greener, and that's because it's not always in direct sunlight, and so water doesn't evaporate quite as much. And so we call this physiography and topography. So the large-scale physical features of the landscape, including mountains and plains, variation in elevation, significantly modify climates. These features influence water flow patterns, drainage, and soil development, creating a diverse microenvironment within broader regions. For instance, steep slopes or rain shadows are areas that can lead to distinct vegetation. So I just mentioned rain shadows. So what does that mean? Well, a rain shadow, wherever the storms come in, whatever side of the mountain they're coming in on, tend to get more rain than the opposite side. And so you tend to see more of a desert effect on the area just after a rain shadow. So you can't see it very well on this particular map, but if we go up to Nevada, I'm going to reset to north, we can see a rain shadow really well, okay, so these are the Sierra Nevada mountains, and so clouds come in, And when the clouds hit these mountains, it drops out all the rain. And then immediately following those mountains, it's very, very dry. That's called a rain shadow. Soil is another really big thing when it comes to development of forests. Welcome to the Web Soil Survey. If you ever want to look at it, just Google Web Soil Survey. It'll be the top result. Anyway, but if you want to know about soils in your area, you can simply come to this interactive map and zoom into your area and figure it out. So let's look at some soils. So here in the West, we're going to go to a Wayne National Forest in Ohio. And Wayne National Forest has some really interesting things down here in a little town called Logan in the Hocking County of southeastern Ohio. Now, in this area, you've got some cave formations and some really beautiful eastern deciduous forests. So let's just zoom in on a forest region here. I am not in particular, I don't know exactly where I'm at, but we'll just continue to zoom in just a bit, and we're going to look at the soil information here. So I'm just going to call this my area of interest. And if you look over here, now I'm going to look at a soil map. Click on my soil map. And you can see it's delineated a line of soil maps, and you can see there's different soils here. We've got something called Cruise Silt Loam at 8 to 15%. We just talked about topography, so slopes are pretty important. If it gets steeper than that, and this is the hill range. This is the Hocking Hills, kind of the foothills of the Appalachian Mountains. You're going to see some silt loam soils. And there's some information here that helps us understand what those soils are, okay? And it gives us more topography information. But soils are really important because plants need to grow. That's their growing medium, right? And so if we don't understand the soil that they're growing in, then that's a problem. Now, Ohio is a really wet in comparison to the western United States. It gets wetter as you go south and east to the eastern United States. So as I back out here away from Ohio, we'll just keep backing out. We can see that this is all a green area. Now, this is eastern deciduous forest. The Appalachian Range is right here. And of course, the west and southwest are mountainous and dry for the most part. So eastern soils tend to be what we consider older soils. They've been around longer. The Appalachian Range is an older mountain range in comparison to the Rocky Mountains and other mountain ranges in the West. And as a result, the soils have been able to weather and break down for many, many, many thousands of years. And adding to the fact that there's lots of water due to waters coming out of from Alaska and then up from the Gulf of Mexico, you're getting two different sources of potential rain, and it causes quite a green effect. And so we got these nice, beautiful eastern deciduous forests up here and the southeastern pine forests down here. Okay. With all of that, what kind of soils are they growing in? Well, these are pretty acidic. They've got lots of organic matter in them because of all the dead material that grows up, dies, and then the cycle goes over and over again. We don't get that in the West because we just don't have that much water as a result. And so the soils are not nearly as weathered. Topsoil is very, very thin, typically here in the West as a result. And so soil becomes a very important part of our discussion. Okay. So soil type, composition, nutrient levels are all critical factors determining the productivity and species composition of plant communities, including forests. So there's things called soil horizons. The very top layer is O for organic, and then right under that, we've got an A and then a B. And as you go down in these soil layers, you get less and less of that organic matter where the nutrients is. And if you don't have nutrients, plants can't grow. And so, yeah, you're going to see a few words like in the reading, like insectisols and spotisols. Those are just soil types, or so there's a taxonomy to soil. And so that's just what those are. And so be aware of that as well. So hydrologic function. Well, the hydrologic cycle is just the movement of water throughout our ecosystem. And this pattern of water availability versus drainage and the interaction between where water, the different sinks of water, whether it's on the ground or evaporated into the sky, and how it fluxes between the two, is a really big and important part of forests. I mean, in rainforests around the equator, some of these big forests create their own own climate because they're so large and there's so much water that's in the air, and it's amazing. So important in North America to look at where the rivers are, where the lakes are, because all of that's going to influence the different freshwater sinks that are available for forests to develop. So hydrologic cycle is going to encompass factors like runoff, something called infiltration rates. That's how water passes down from the surface into the soil. The presence of a wetland is also important. Wetlands are indications of lots of water in the soil. So so water is a hydrologic function is a very important part of whether or not you have a forest around. So as we look at the United States, and we've already talked about the differences between the eastern United States and the western, we also have to think about potential, okay? With soils, with topography, with climate, each area is going to have their own potential for what kind of plants can live there. And even if you go into the Salt Lake Valley here, you're going to see some beautiful streets with trees and all sorts of things that make it look absolutely gorgeous. If you look at this, is a place called right here, Sugar House Park. This is Sugar House Park. I lived right close to it for years, a couple of years, and it is gorgeous. It's got trees and all sorts of beautiful things in it. But this is all artificial. These trees were all planted and they're sustaining climate. Water is all artificial and not natural. And so if you went into Salt Lake Valley back when it was originally settled, you would not see these nice tall trees except for maybe along streams. Okay. And so in those situations, it's not normal. So what is an area's actual potential? It has to be asked. Okay. What is the potential of the area? And it takes into account all of those things that we've talked about thus far. And so typically speaking, we expect that there will be an understory of about 25% at least. And so as you go east, you see more and more of that potential. These are grasslands. These are tall grasslands here in Missouri. And then as you get into on the east side of the Mississippi River, then you get into areas that are naturally more likely to have forest lands as part of them, because they have all the right characteristics to allow that to happen. Down here in the southwestern United States, where do we see that natural habitat? Well, right here on Mount Graham, we've got the potential climate, soils, nutrients, topography, all of that's playing a role in order for a ponderosa forest to survive, develop, and as we've talked about. So the boundaries between ecological sites, we've mentioned all of the characteristics that are needed, whether it's soils or climate, and so climate really is the big one. Aspect and topography, slopes are all very, very important. Soil moisture, of course. So if you can find a way to have wet soils, even without the precipitation, then you're good, right? But boundaries are broader and kind of hard to define. As you go up mountains like Mount Graham, the actual lines between these ecological sites are very hard to distinguish. You'll be in one spot and then you'll say, well, it's starting to change. And then all of a sudden you'll be in another spot, but there's no delineated line saying, hey, you've just crossed over into a forest versus the arid desert. And so those lines or transition zones that we like to call them are very hard to identify. And as a result, it's crucial for effective forest management in order to help the natural cycles of things to occur. Without forest management, then we get things like large wildfires and really significant, perhaps overpopulating of specific species or invasive species come in and cause issues.